my mind was blown this week. My mind was blown about AI, and I just wanted to share how it was blown and how I see how I want to move forward actually, and 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 maybe use these AI tools in a completely different way to the way I've been using them up to now.
Mhm.
So this all started with a podcast that I listen to, video series. So the person who creates this content is Angela Collier. She's on YouTube, that she produces longish form content on YouTube, which I love, and anything she does I think is amazing. And she had a video recently about called vibe physics. So this is relating to the concept of vibe coding, right? So I guess, have we talked about vibe coding? I don't know, in any podcast.
I don't think we've used that terminology.
I don't believe we've used the terminology.
I think I've talked
Um,
about it being useful for writing silly apps that I write, so,
yeah,
or making silly apps that I make.
but I think we haven't talked about it yet. So maybe just a couple of words about vibe coding, then what is vibe physics, and then what is vibe writing. And so then I'll
Mhm.
explain as we discuss this
Mhm,
where exactly my mind was blown.
mhm, mhm.
So vibe coding, which I always thought was a stupid piece of terminology, and I thought it meant you just ask AI to write your computer programs for you with a couple of prompts. Write me a flight simulator, and then it writes you a flight simulator, but everything doesn't work or whatever, right? And there's all these quite entertaining videos on YouTube about how vibe coding leads to complete chaos. And I thought this is never going to work, right? Because no company will accept code written by AI because there'll be security holes all through it. It's a disaster waiting to happen. That's what I
Of course,
thought.
that's not true, right? Like,
It's not true. Yeah,
wasn't like,
yeah,
was it one of the major companies like Meta or something, or Amazon, that said like a quarter of their code is written by AI?
yeah, yeah. And
Yeah,
that already scared me because I
yeah.
thought like, oh my gosh, this is a disaster waiting to happen, right? Um, and then so the idea of using AI to write serious code has always been kind of laughable to me. I've tried to use it to write stuff, computer
Mhm,
programs, and it's super duper useful to get you a little program to do something. You can sort of quickly
mhm,
write me a program that multiplies two matrices with blah 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 entries, and then it'll do that, right? And it comes out with and it saves you a lot of time that way.
mhm.
And I thought, well, that's obviously how we're going to be using AI. Done, right? That's it's never going to revolutionize coding. You're still going to need expert knowledge. And then, of course, this vibe coding thing happened where the idea is that programming is now going to be accessible to non-experts in programming. Apparently, so is the idea, right? So even if you've never written a line of code in your life, you could technically just with some prompts get ChatGPT to create a web app or whatever, right? And that's where I think like, oh no, this can't. I feel icky about that, right? And then comes Angela Collier's video on vibe physics, and this is like taken to the extreme. So
Can I
the
ask
uh,
why
the
you feel icky about that thing you described?
um I'm actually going to explain it with the vibe physics because I think the
Okay,
vibe
sure.
physics takes it to the extreme, and then
Okay,
you'll see why I feel uncomfortable
okay.
about non-experts or non-trained people using
Mm,
AI to write computer code. So there was recently some billionaires who for some reason or another they feel it's important that they are known to be good at physics. So various billionaires go through this thing where they all feel the need to be seen as I could have been a great physicist. And there's many examples from Bill Gates onwards,
mhm.
and Elon Musk, of course, is a classic example. And recently, the CEO of ex-CEO of Uber is Travis, someone I forget his name, was in some podcast talking about how he was using ChatGPT and how ChatGPT brought him into the topic of physics, and then the questions he was asking brought him to the edge of research and brought him to extremely deep ideas in quantum physics and the nature of the universe. And and how he could see that these deep he was capable now of doing deep research that would be
Mhm.
challenging the fundamentals of science. Now, of course, to any physicist, right, this is completely laughable, right? Because ChatGPT, if you ever used it to assist you in a trivial way with research, to vibe research, right? Write me a paper on the connection between muons and biochemistry, right? It'll come up with something to do with muons and biochemistry, and if you're not an expert, you'll be like, oh wow, this seems really convincing, right? Because it's really good at bullshitting. These LLMs, they're super good at bullshitting. And so, as a non-expert, they will convince you rapidly that what they've created is legitimate contributions. To a non-expert, you have no way of discerning the nonsense from the actual legitimate ideation that might be useful for you. And so in the physics context, it's really in the extreme. If you ask it to come up with deep ideas in physics, it will come up with deep ideas in physics, which are total and utter nonsense. And yet, even the expert will have a little bit of a time parsing through what it creates to realize why it's total nonsense. I've been fooled more than once, right? I've asked it is there a connection between X and Y? And it found one amazingly, right? It always finds that connection. And then you look at it, and there's these equations which look tantalizingly correct, and then you look at it a bit more, and then about half an hour later, you're like, this is just garbage. This is total garbage. But it's dressed up in such a way that the non-expert will never detect it, and even the expert is a bit. He has to invest time to work out the difference. And so this is this vibe physics. So the non-expert think that they're doing amazing physics, and every expert is like, this is completely laughable. And that was my feeling about vibe coding, right? I was thinking, well, if you don't have software engineering background, how are you going to know if it's producing stupid stuff? You're not an expert. You don't know if it's checked stuff into GitHub and maybe erased old stuff, deleted old stuff. How would you ever know, right? You're a non-expert. You have no experience in the software engineering, and so that felt weird and wrong.
Yeah.
So I don't know. Maybe you could respond to that first, and then
Yeah,
I'll move to where my mind was blown.
Man, I have like 8 directions that I would love to go in. This is like such a fascinating topic. Yeah, I'm glad you brought it up. Okay, so my initial thing with the vibe coding, I feel like I don't have that icky feeling about it that maybe you do. But as with all these things, my thinking about it has changed like over time. So my first thought about like the difference between coding and physics is like coding, there's an end goal, like you're trying to create something. And if let's say you're trying to create an app, and if you like tell some AI to like build you this app, and it's built the app, you're like, okay, I've succeeded, like I built the app.
Yep.
Great. Of course there are dangers associated with this. One of them is security, right? Like if your app is going to be taking in like personal information, you need to make sure that it's secure. So I don't know whether did you hear about this app T that had this massive leak recently?
No. Oh no,
So
I saw some headline, but maybe you can tell me,
yeah. So
and I
this
can be
app
entertained.
was an app for like women who were dating men to get onto it, and then share reviews of guys they've dated, so that like probably for good reasons, maybe this guy is like really bad, but also I can imagine it being like weaponized and used in a bad way. Like I kind of whatever. I don't think it's great that this app existed, but it did, and I guess a lot of people like got a lot of use out of it. But anyway, then there was this leak on 4chan. They released all of the, I think it was all of the licenses that people like driving licenses, whatever that people
Oh my gosh,
uploaded for
yeah.
identification, all their selfies that they use for the identification, and all the DMs. So like you can imagine that this was like a disaster. And I don't know like if there's been an investigation into what happened, but I think a lot of people were suggesting that this app was vibe coded and people didn't really like take the security aspect of it seriously. So there is an example of like, yeah, it seemed like the app worked, but it didn't. So yeah, disaster. But I do believe that over time, it would be possible to create, some kind of platform that has in the back end all of the security features in place, that connects to your databases in a way that takes care of all of the secure stuff, that does it in such a way that you're not going to be an idiot that like is going to delete your whole code base, which is also something else that happened. I don't think we're there yet, but I can imagine that being something that exists in the future. And a lot of people do talk about how like software is going to change rather than people, companies building software for the masses. People are just going to be like creating their own like bespoke software whenever they need something. So
Yes.
for example, when I started my company, I didn't like QuickBooks, and so I built my own bookkeeping system in Airtable, and that like took quite a bit of time. But I can imagine, in the future being like, build me a QuickBooks clone that has these features that doesn't have these features, and it builds it, and I just use that. It's just customized for me, and some software building AI like built that. Like I think that is a future we're going to. I think there's a possibility that that future can be safe, like from a creating safe software perspective, and like I don't think it's necessarily bad. Like giving people the tools to like custom build their own apps is like a very powerful thing.
Yeah, I don't want to sound like I'm gatekeeping here. The
Sure.
icky, I guess that probably came across as me gatekeeping software engineering. It's just like I couldn't past tense
Yeah.
imagine how you'd overcome these safety issues and so on. But you've already said something very interesting, namely about this idea of the backend, a product which is secure backend. That you presumably that's a product that some company will come up with sooner or later and market to people vibe coding. You vibe code the app and then you're a bit worried about security, so you purchase this backend
Yeah.
product, yeah, that is
I mean,
safe.
already there's like kind of smaller versions of this. Like, if I wanted to 20 years ago have some kind of app that like took payment, from people's Visa cards, it would be really difficult for me to like build that and
Yes.
create that safely. Now there's all of these APIs. I can just like plug into some like
Yeah.
Stripe
Right.
API. Like I just
Of
need
course.
two bits
Yeah.
of code, and it handles all of that like security in the background. I don't have to deal with like protecting people's credit cards.
I see.
So,
Yeah.
if there's this
It's just a
whole
matter of time,
marketplace of
right? Yeah.
APIs, like I think it should be able to, you need to trust the companies that own those other things, but I can
Yep.
imagine that. So yeah, I'm kind of optimistic about the whole vibe coding thing. I do think that there is this issue of, like if you really want to understand what's going on behind the scenes, like you miss that. You don't get to like learn how to write code. you're,
Hmm.
you're not a coder, you're not a programmer, you're not a hacker, but you have the power to create apps, and they're just like different things. Those things used to be synonymous, and now they're like separated. And
They're quite
so
separated.
yeah.
Yeah.
um for the physics thing, I want to ask you a question, because I also
Yes.
like kind of, my mind keeps changing about this. I've been, and I don't want to like monopolize it, so I'm going to just dive into the question without context. But
Okay.
just because I'm asking this question doesn't mean that I am sitting on one side of this. But my question is, why? Yeah, why do physicists get so up? Okay, two questions. But yeah, this is the more inflammatory. Why do physicists get so upset about people doing physics maybe wrong? So like, there seems to be this like animosity about these billionaires who are like claiming to do physics, and also
Yeah.
like
Yeah.
it comes up with like the crackpots, like crackpots who
Yeah.
are
I mean,
emailing them,
a billionaire
and I
equals
remember
crackpot in this
yeah,
discussion,
and it's
right? Yeah.
like
I mean, but yeah, we
like
have denizen
why
science. Yeah.
why do you get like
Why do you,
so upset about it? Because like if someone's like a musician, right, and they, it takes so much work to become a good
Mhm.
musician, so much talent and everything, and then there's like other people who like just are not professional musicians. They just like put together some tape and like send it to you. Like I doubt, maybe they do, but I doubt they're all sitting around their lunchtime table and like making fun of all of these people who like sent them this tape, and like clearly this person doesn't know what it takes to be a musician. But like physicists do this all the time. They
Well,
put so much
there's a song
effort
about this
into
from De La Soul, right? You know,
like
Ring Ring.
what's that?
The De La Soul song Ring Ring.
I don't
Where
know. Oh,
where they're talking about the some idiot handing them a demo tape at the end of a concert.
okay.
That's the
Well,
whole basis of the song,
maybe
right?
they do it. But
They
it's
do. They,
cool. And I did this. I participated in this a lot as well. Like
yeah.
physicists seem to like spend a lot of time like defending against other people doing physics wrong, and I kind of feel like just ignore it. Like, is it
Yeah.
doing any harm? And so I guess yeah, my follow on questions are like, yeah, and I guess it's like ties into the initial thing, like whether, and yeah, so the question about whether like vibe physics is bad or good is about what is the point of doing physics, because depending on like what your goal for doing physics is, you're going to either decide that vibe physics is good or it's bad. And so yeah, my two questions to you are, why do physicists care so much about this, and what is the point of physics?
Okay, so I'll answer them, I hope, snappily, both of them.
No,
So
well,
the first,
we've got lots of time.
no, I know we got infinite time, but I also think in terms of listening to me, at some point you just want me to shut up. So
No,
yeah.
I've been dominating the conversation.
Okay, answer to question one: why are physicists so defensive? So it's twofold answer. It's resource allocation and also gatekeeping, right? So we have very limited resources as physicists. We invested a tremendous amount of energy, and there's a huge opportunity cost to becoming a physicist, because you have to study for 3 plus 3 plus whatever years to become a card carrying physicist.
Mm-hmm.
And so you're naturally defensive of this. It's like the classic immigrant thing. You come to another country, you go through all the hoops to become a citizen, and then you're like, these immigrants, right? You become resentful of people who are taking resources away from what you've invested so heavily in. And so that's, I think, one.
But do the crackpots and the billionaires like fit into that category?
No, no. They certainly don't. But that doesn't mean that people don't act irrationally. The first thing you want to do is you have your in group, your tribe, which is the other people who validated you and given you access to the group. And then you want to clearly define the in group and the tribe against the out group, which would be anyone who's not studied for 6 plus X years.
Mm-hmm.
And that's just human behavior. I think that's nothing to do with being logical or whatever. It's like, I'm in the tribe. We got to defend the tribe. We got to look after each other. So that's one answer to. And the resource allocation thing is, we don't want people coming along stealing any publicity, any limelight, or whatever, because we're concerned. We're concerned that resources might go to the wrong place, or they may be even wrongfully taken away from us. So examples being super colliders and other mega projects, they can be killed by non-experts or non-physicists on political grounds, which are invalid, right? So that would be my two answers to that question. And then you asked about the point of physics. I mean, you hit the nail on the head, right? What is the point of physics? I don't know actually.
And so, I mean, I can tell you. Well, maybe I'll. Okay, so like I've come across this idea of vibe physics actually like a few times recently. Maybe even like as far back as like 6 months ago or longer. I was talking to this guy who's actually like, he went and made gazillions of dollars with some startup, and now he's like building a platform to help researchers, an AI, essentially an AI co-pilot to help researchers do physics.
Right. Mm-hmm.
And when I first encountered that, and I was chatting with him, I think I was like pretty rude and dismissive, and I was like, this is the dumbest idea in the world, because like when people are doing physics, they're doing it because they are like, to me, like I do physics because it brings me like immense internal rewards, like just going through and doing the physics. And that's how I did my whole career, was just for my own internal satisfaction. And so the idea that now I'm going to be handing that off to a co-pilot, to me was like ridiculous. Why would I want someone taking the fun away? I'm doing this for fun. Right. And so to me, that seemed like a silly idea. Then some other people later in my kind of tech community, ex-physicists as well, kind of kept pushing this idea, and were like, well, what if, like you are a practicing physicist, and like interacting with this thing actually like helps you make these like huge like leaps in your thinking, that you will like discover some new idea. And then I was like, okay, yeah, actually, like maybe a lot of people do physics like for other reasons that are not just like because they think it's fun. They do it because they're trying to achieve something. And I think that's always something that was like, I was always missing that big picture as a physicist.
Oh, I see. Yeah.
And so in your like, let's say, like hypothetically speaking, if the AI could help you like create a new field that never existed, and like create this like whole new like amount of opportunity for all of these physicists now, like would you be down for that?
I 100% would be down for that, and this is where my mind got blown. This
Yeah.
is
Okay.
on this
Okay. Oh,
exactly
right. We're getting to the
yeah.
good thing now.
We're gonna get
Yeah.
we're getting to this like, but I'd be 100% down for that. But the problem was I just couldn't imagine. I tried out the tools and it's just they seem so substandard to me. Like I
Mm-hmm.
just like it they're useful for taking a little bit of grind out of research, but that not even that, right? You know, I don't even trust them to do a literature search. Um, but this week I discovered that one of my favorite all-time programmer guys, Steve Yegge,
Oh,
has
yeah.
a new podcast.
Oh,
Uh,
nice. I didn't know about this. This is great.
a podcast with a guy called Gene Kim,
Okay.
and they're talking about their new book that they've written called Vibe Coding: Building Production Grade Software with Gen AI, Chat Agents, and Beyond.
Okay.
And generally speaking, when Steve Yagi says anything, my mind, I feel like I advance my understanding of the world. Uh,
Mm.
and this was seriously shocking to me, what they're talking about. So they have, in the past 6 months, found a way to be productive with LLMs, vibe coding, but they don't do it in the way that at least I understood that you did it, which is you put in the prompt, you get the thing, you try and compile it, and then you say, fix this mistake. No, no, no. This is not what they're doing. So they're doing something called agentic programming. So this is, I didn't know this was a thing. This is a thing where you set up a feedback loop. So you get many LLMs. This is the key point. You don't just get one
Mm.
model. You get Claude, you get Gemini, blah, blah, blah. You get as many as you can, DeepSeek, and you all ask them in parallel to work on some small, well-defined task. They give you the answer, and then you test it. You set up a framework where the output of the program is automatically fed back into the LLM as a prompt, so you don't actually interact any more with the prompting. Like it runs in a cycle.
Mm-hmm.
And if you set up this feedback cycle, and you've got to set up testing, so this is very important. You've got to set up ways to test, right? So if you don't set up tests, then of course they'll produce complete and utter garbage in these feedback loops. But if you set up proper testing and proper design
Mm.
specifications, like I want it to do this thing. How do I know it's done this thing when it passes this test? And you've got to, you know, update the program until it passes the test. And they're talking about how they're creating huge software projects by just watching. You know, they set up this loop, and then the LLMs go to town. They start creating the thing, testing the thing, getting automatically a new prompt, and they just watch it scroll past on the window until they end up with correct programs to do X, Y, or Z.
Mm-hmm.
And it's that moment where I thought, okay, now I can see. Now I see a pathway to using LLMs to do scientific research, because how do you test the validity of something in maths or physics, right? It's going to be a correct
Experiment.
derivation, right? It's going to be correct.
Okay. You're thinking differently then.
I'm thinking a bit differently, and
Yeah.
there are tools to check correctness, right? It's
Yeah.
if this thing, theorem proving software and so on.
So you're thinking it from the math perspective. You know something is correct when it's being derived correctly, but that's
Yeah,
not physics, right? Like, because you
that's
could
not
be doing
physics.
all
No, no,
sorts
no,
of
no,
things.
no. But that's
But
one of the key stumbling blocks that
yeah,
I just couldn't imagine. I couldn't even imagine how to use these tools, because it would produce these hallucinated
yeah, yeah, yeah.
eldritch horrors of research. And but now you can insist in this loop, in this feedback loop, you haven't succeeded until it passed a theorem checking uh, piece of software. That's one of the tests, right? Another test might be it's got to achieve the goal that you wanted it to connect momentum creation or whatever in some system with some other system, right?
Yeah, this is okay. This is great. This is so great. By the way, like the test thing, like that's something that has existed in software for quite some time now.
Of
It's
course,
called
yeah, yeah.
test driven development, and it's
Test-driven
actually
development, yeah.
how you get so many different people working on these massive code bases that when you write a little function or whatever, or a class that does something, you also then have a whole bunch of tests that you would
Mhm.
run that automatically check whether that thing is doing what it's supposed to do. And a lot of good software design is coming up with good tests that cover all the edge cases and stuff.
Yes.
And so then when somebody else comes in and changes the inner workings of this function or whatever, it still has to pass the tests before you upload them into like the latest version on GitHub. And so
Right,
then,
yeah.
yeah, this question of vibe physics is, how do we test things, right?
Exactly.
and
Yeah.
so I think this is super interesting, and I think it's super interesting that we went off in like completely different directions, because the direction I went down was, anytime you have a physical theory, like crackpots can come up with all sorts of physical theories, but unless somebody tests that against like reality, you can't tell
Yes.
whether it's like real or not.
It's a
And
good point.
I
And
feel
physics
like
is kind of about that. Yes.
in, in the past, I feel like in order to get your theories tested, you would need a lot of social capital to get an
Yes.
experimentalist to agree to do your
Resources. Yeah.
test. Like
Yeah.
often the experimentalist that agrees to do the thing doesn't actually deeply understand your theory, right? Like they're going to do the experiment because maybe they trust you that you
Yeah.
did the theory correctly, or they're excited by your theory, or they're your friend, or
Yeah.
there's a consensus around the community that you should like test this. But one thing that I find super exciting right now is, I don't know whether you've been following it in quantum computing, but so like quantum computers, uh, the idea is you make this computer and then people can like run stuff on this computer.
Mhm.
But nobody, these things are like hugely expensive. No one is going to be like building a quantum computer in their like home. You
Mhm.
access them through the cloud. So
Yeah.
all of these computers have cloud access. You jump online, and in fact, what's funny in the industry is now people who work uh, on using the hardware, they're called experimentalists, even though they like don't go into the lab. They're like,
Right. Yeah.
on their laptop, like accessing these things. And what's exciting to me is that there's kind of this like offshoot from the computing thing, which is that they create these, very sophisticated, let's say, ion trap or neutral atom device or something. And yeah, you can use it to make a computer, or you can use it to do physics. You
Right.
can make a BC that you can access on the cloud. You can have an ion trap that you can access on the cloud. You can, in principle, imagine all sorts of physics experiments that are accessible on the cloud. And now, any person who maybe is not an expert or not a trained
Yes.
physicist or doesn't have access to these resources could be running physics experiments on the cloud, or an AI agent could be running physics experiments on the cloud. And so maybe part of this loop is like, it
Yes.
comes up with some theory, sends it off to a BC, like somewhere, whatever, on the cloud, and then, checks it and goes on. So you can imagine like all sorts of super interesting things
I
happening,
mean,
that when people have
this
more access to experiments.
100%. I literally get goosebumps when when you're talking about this. This is that's I think that's super deep. Like if this can happen, if we and it has
Mm-hmm.
happened, let's admit it. I mean, I I even remember the day when I realized that it happened. I was sitting in Steve Flamia's office in Sydney about 5 6 years ago, pre-pandemic actually, pre-pandemic, and and we had just IBM had just released their first on cloud access to their
Mm-hmm.
5 qubit devices.
Yeah,
Yeah, 2000. It
yeah,
must have been 16, 17, something like
yeah,
that. And I, I literally not even touched it or looked at it. And I was in Steve Flamia's office, and he said we were talking about it, and one of his students was there, and they actually had the window open or whatever. And he turned and he said, "We're all experimentalists now."
yeah, yeah,
And I was like, oh, that was the aha moment for this. It's like, yeah, right. The
yeah,
minute it's on the cloud, we're all experimentalists, and experimentalists got quite defensive about this stuff at the
sure,
beginning,
yeah,
but now they know they can make a shit ton of money selling
yeah.
cloud access to their experiments.
Yeah, and so
So
you can imagine them, doing the same arguments. You're not really an experimentalist because you're not there twiddling with the thing. You're not there
yeah,
aligning the bits. You're not going through all of this hard work to like build the internal workings of the experiment. You're just using the experiment.
yeah,
And
yeah,
and I guess that's how like real coders feel about people using
yeah.
software, like whatever. I don't know, like
I can totally imagine this. Yeah, but yeah. So it's super exciting, this idea that we could have cloud access to multiple experiments, not just quantum computers, but as I'm just repeating what you're saying because I find it so profound. Um, and then agents, you could be using this agentic programming paradigm to interact with the experiments. I mean, oh my gosh, right? That's the future that I want to live in. Um,
yeah, but
and
also like I just have this deep sadness because doing all of that, it's painful, but it's just so rewarding. And the AI is taking away this like huge, deep satisfaction that we can gain from developing expertise. Like that is just
Yeah,
like so
but this is the
meaningful.
other thing that that I was convinced of by these two guys talking about this Steve Aggie guy, and they said there is still a role for the expert in these feedback loops, and that is you are the one who determines what has value, right? So
Yeah,
and they have this analogy which I found very helpful actually. Trying to say it's like you're in a Michelin star kitchen and you're the head chef. So now you've got all these like under chefs, these sous chefs, and the dishwasher and so on. They're doing the jobs of the restaurant. And you're the head chef. You're the one that goes around and samples the dishes to make sure that they taste good and they meet the standards that you've set up for your restaurant. And I like that they use this analogy over and over again. I think that that's the right analogy, right? It doesn't take the joy away. On the contrary, you get to be the head chef instead of a sous chef or a line chef.
yeah. No, I agree, which is great if you're already an expert. But how do you become
Yeah,
an
yeah.
expert
How
if
do you become an expert? Yeah,
you
still got to
don't
grind.
get to
Yeah,
go through that? Yeah, I don't know. Maybe there is. Maybe there is a way. We will have to just define like a different learning path that isn't the apprenticeship model, like a
I
different
guess.
learning path
Yeah,
to get to expertise without having to like do all the steps in between. But I can't imagine it right now. And I feel like this
yeah.
is one of the problems that's it's not just an AI problem. I think it's just in general a technology problem that in the past I feel like uh the path towards expertise was so long that along the way you also developed a whole bunch of judgment that allowed you to then use your skills in a good way, like
Mm,
architects or artists or photographers or whatever. And then as it became easier and easier to do this stuff, like anyone could in principle take high quality photos, they could do that before they had the time to develop taste and judgment and
yes.
know how to apply that technology in a skillful way. And yeah, I feel like that's just happening more and more and more. Like now, anyone can build an app, but are they going to build a good app? Probably not, because like they never developed like a lot of the things you need
They
to
don't know anything about
judge.
UI, UX, or whatever. Yeah.
Yeah, yeah. So I don't know how you get to be that head chef if you never got to like go through all of
Yeah.
the stages
Well, I
before.
think this is. I would just say this is the role of humans, right? We're not obsolete, and it's painful and expensive to become an expert, and it always will be.
Mm,
Um, photography is interesting, actually. It used to be ridiculously hard to get into photography, right?
mm,
Before digital cameras, and uh, and when you had a photographer and you met a photographer and you employed a photographer to do a job for you, like they produce damn good photos,
mm,
and
mm.
you would be impressed. And these days, like, has uh, has the job of photographer been truly supplanted, or do we still have expert photographers? I just haven't interacted with a photographer in a long time. So, do you know
Um,
this?
we I think it hasn't. I think when you're hiring a photographer, the most important thing that they can do, apart from lighting, I think, and having good equipment, I think the most important thing that they can do is to make you feel relaxed and make you sit in a way that makes you look good or
Haha,
look in the way that you want to look. And if someone who you don't have a good rapport with is taking photos of you, you look really bad in those photos.
interesting.
And
Yeah.
they need to be able to
So,
see like this side of you is the good side, this side is the bad side. Put your shoulders
mhm,
like this. I think it's that
right.
human
Okay,
thing
it's that
that
human thing.
makes someone a
See,
good
very, very
photographer.
interesting. I actually asked about this because I that's kind of a sign of times to come or an indicator of
Mm.
where this progress is going to go because
Everyone's going to
the
need to be a people person.
I think the role of people becomes more and more important.
Yeah, I
The way
agree.
we interact with each other, right? And I said that in an earlier podcast about teaching. Like I just think we are not going to reach the point where we're going to reach the point where all education will essentially become an oral form, right? Uh, an oral tradition because we'll be talking with each other, we'll be testing each other's
Mhm,
knowledge, and the only secure, definite, clear way where we didn't have access to an LLM was if you talk to them, right?
mhm, mhm.
In an oral exam setting, or not, right? If
Until people have LLM implants in their
well,
heads
when they have
and
implants, then we're screwed.
No, but this actually, I feel like this is a general theme that has been happening recently, and I don't know why, but it brings me no shortage of joy that
Yes,
we're kind of
yes,
like going back to the 90s
100%. Yes,
in
yeah.
so many things, like all the AI slop on social media like is making people spend more time in like reading curated blogs or hanging out in like private spaces or hanging out even in the real world in
In the real
meetspace.
world, yeah,
They're like
yeah.
interacting with people. Another thing in software development, which I think has been very interesting. So there was this movement. Have you heard of the waterfall as like a project management methodology?
I have
So it
heard of
doesn't
it, but I
matter.
don't even know what that is. Yeah.
Yeah, so it's essentially like what you would expect project management to be. Like if you want to build a bridge, you need to like make plans for 5 years about what to do
Uh huh.
step by step in order to like
Hmm.
build the bridge. Then people found, I don't know whether it was like the 90s or sometime, they found that that's kind of a silly way to build software because
Hmm.
software, uh, it's better to build it in an iterative way, to be more agile and whatever. And so this kind of led to this software development approach called Agile.
Hmm.
And so there you have these like feedback loops. You're just building things iteratively, interacting with the customers, bring that back into the design, and it's very like kind of evolves almost organically. And I always like, I mean, I really love that approach to doing things, but I felt that it was applied in areas where it shouldn't have been applied. So I feel like in developing deep tech, like people were trying to do, build agile teams to do that, build agile teams to do quantum computing. And I just thought
Yeah.
that was like, we should really be doing things the old fashioned way, the more waterfall method. And
Hmm.
now, because of the thing you described earlier with these agentic things, how you have to
Yeah.
set up all of these guardrails, all of these tests, people are now going back to the waterfall method in
Exactly.
software
Exactly.
development
Specifications, right? Yeah.
because you need to really like plan things out very carefully to let the agents do what they're supposed to do. And so yeah, I just feel, I don't have the examples on the top of my head, but I've been seeing this a lot. Oh, even like with SEO, like
Mhm.
that's all changing now as well, because like um the way search interacts with things, like, so I just feel like a lot of things, like people are just going back to like the way they used to do things in the 90s and the
Oh yeah,
2000s.
this brings me great
Yeah,
satisfaction and
yeah,
joy.
yeah.
Yeah. I want to live in that future, and also it brings me a lot of optimism that the role of it clearly defines the role of humans. I think
Mhm.
in a future with artificial intelligence. Uh, I don't believe in any form of singularity nonsense. Like, have you ever seen a robot try and fold washing? Like,
I've tried to use a robot to fold
yeah,
washing, like doing this thing. It's
uh,
bloody hard.
it's bloody hard, right? Interacting with things outside of a simulated domain is extremely
Yeah.
challenging with these reinforcement learning tools. And it's in terms of automating experiments. I actually have a paper that we just
Oh,
published. Very, very,
congratulations.
humble brag. But actually, it's not. I played a very minor role in this paper. It's truly an accomplishment of a PhD student that I
Mm.
jointly supervised, Leah Richman. Um, she and another PhD student of mine, Victoria Schmiesing, they had the idea of using reinforcement learning tools, like the absolute state of the art AI tools, to automate bits of an experiment. It's an optics
Mm.
experiment, and it's the most, and like, if you could do this easily, then you could really start to automate large parts of experiments, and you don't have to sit there as a grad student like aligning things anymore, locking lasers or whatever. And so they tried this out with absolutely the most cutting edge uh, AI tools. And what job did they automate? They were just doing beam finding, right? You're just trying
Mm.
to get a laser to mode match into a fiber, right? So it's something that a grad student would have to do in the old days. You put a little
Mm.
card in front of the laser, you see where it approximately is, and now it's getting into the beam, getting into the fiber, and then you have to kind of twiddle some servos or mirrors in order to get the laser to go as good as possible into this fiber, right? And there's something called beam walking, where you just sort of you keep twiddling backwards and forwards, and
Mm.
you optimize the
Yes,
intensity.
yes, I remember doing this in Andrew White's lab for my
Yeah,
three
yeah,
months.
there you go. I thought you, and
Experimental.
it's it takes a couple of minutes, right? And an expert who's done this a lot can do it. I think they did 30 seconds, right? You can get
Mm.
really good. And so they tried to train just just this task with two servo motors to do this task,
Mm-hmm.
and it was freaking hard. And
Do you think maybe it was
these
overkill, like using such a sophisticated approach? Like I can imagine like a much simpler
yeah,
model or something like
yeah,
that.
but this is the of course. I mean, there's very very simple feedback loops you can build to do this optimally,
Mm-hmm.
right? But that's not the point. The point was
Mm-hmm.
we were trying to assess, can AI tools replace humans in the lab or in
Mm-hmm.
physical, and on the simplest setting at all, right? Which was two
Mm-hmm.
servo motors. And the answer was yes, you could, but it took an immense amount of training with real things.
Mm-hmm.
And that's what it costs so much time, because in the end, it takes a little bit of time for a motor, a servo, to move something. So the AI wants to train, it wants to get
Mm-hmm.
training
Mm-hmm.
data. And so it takes physical time to move stuff. And it wants to do it at the speed of light. But to get this precious training data, it was taking hours and hours and hours of this motor going
Interesting.
backwards and forwards. And in
So
the end, they
okay,
trained it.
this is interesting because I'm definitely not an expert on these LLMs or anything, but from what I understood, you know, they can be trained on one kind of data and then used on other kinds of data. So you
Mhm.
could train it like just on language, just on books,
Yep.
and then suddenly it can do math, and or suddenly it can do like I don't know, like image stuff.
Mhm.
Um, and so I wonder, okay, because this is like a thing now that people are talking about. That when they're trying to build AI that does things in the real world, they need to collect more and more data in the real world. So people are talking about, like maybe, you can buy data from people wearing wearables and walking around and just collecting, how
Mhm.
they're interacting with the world, and that can be used to train these models. And so I'm curious whether you can have kind of real world meet space models that are trained on stuff that is completely different to what's happening in that lab experiment, but then later could be applied to that experiment, or whether
Um,
you have to train these things on, that specific physics experiment.
watch this space, I think, is the answer. That's the next thing we want
Yeah.
to try out. So it's not an LLM, to be clear.
Okay.
It's a totally different form of artificial
Sure.
intelligence called reinforcement learning, where you have an agent that interacts with an environment, and you try and get the agent to behave in a way to optimize some
Yeah.
objective function.
Yeah. So there you're telling it, correct, incorrect, correct,
Exactly.
incorrect. You're
Yeah.
giving it feedback and it's
You
learning
give
from it.
feedback and it's learning for that.
Yeah.
And
But I wonder.
unfortunately, like training an LLM is easy, I would say, like in comparison to training a reinforcement learning agent,
Mhm.
where it's very expensive. So there's no way we know yet to speed that
So what was
up.
the rationale for, yeah, you choosing a reinforcement learning approach rather than an LLM?
um, well, we tried a combination of all in the end,
Okay.
and that's the model that worked. And so
Okay.
can you transfer this to another experiment? We don't even know, right?
Mhm.
That's it on the to do list. Uh, and so
Yeah, but that's super interesting.
I think there's a you might say, okay, imagine in the most optimistic of all futures where you could transfer this easily to other settings, this trained agent, which I don't believe, by the way. I think there's serious challenges to doing that. Would we enter the singularity situation where like AI takes over? I mean, it's just absurd. Um, you know, I will officially become worried about the singularity when the first AI folding machine comes out. That's my metric for 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 my concern about an AI dominated apocalypse. Is this, if you can build a robot that folds washing, I will get scared, because transferring, I think that it just is, from the experience we've had with that two damn servo motors. um, I don't know how it's going to transfer to three servo motors, or it's just,
Mm.
there's just so many unknown steps, so many hail marys that
I don't know, but at
everything's
the
got
same
to go
time,
right.
I mean, you've seen all those robots, like the Android robots, or the like the Boston Dynamics dogs
Yep.
that they like kick the crap out of them, and they like
Yeah, they
like
stabilize and
I
so on.
mean,
Yeah.
the you know, obviously amazing progress is being made with like robots. So I don't. I'm starting to feel like as if I missed something about this like uh washing folding thing, because like I'm seeing a lot of people refer to it, and I even
Oh,
am being
okay.
encouraged to it, and then I realized that there must have been some demonstration like of a robot folding thing that didn't work.
I learned about this of an
How did
ancient
this
Hacker
pass
News
you?
post, maybe back in
Okay.
2000, early 2000s. There's a guy who was obsessed with automating washing, folding. Like
Okay.
he had a personal grudge against folding washing, and he spent decades of his life apparently trying to find a way to build a machine that folds washing.
But why is it suddenly coming up? Like, I feel
I
like in the
don't know
last week,
actually.
I've heard like 3 separate references to
Interesting.
washing,
Yeah,
folding, and folding,
I
washing.
haven't heard about it since I read this article actually. So,
Okay.
and I also personally have a grudge against folding washing. So maybe you're googling it now. I don't
Okay, for me, folding washing is like the only time I can listen to podcasts.
know.
So I always like need more washing to fold.
Oh no, I got other jobs that we can do for that.
Yeah.
Um,
Um,
so
Interesting.
yeah, I believe I'm eternally optimistic with the AI future now, and I'm hoping that this agentic paradigm will actually enable vibe physics in a true sense. And I found it super interesting how we both had this different answer of what it would mean to test it.
Yeah, yeah. Because isn't yeah, I always feel like all the
That's the difference
crap.
between a theorist and an experimentalist, huh?
I'm not even an experimentalist though.
But I mean, in this case, you're proxying for
Yeah, yeah.
experimentalist.
I think the term is expery theorist.
Experi theorist, yeah.
Yeah. No, okay, this is like the story of my life is that I'm always the other, like whatever it is, because I always okay, like the business I'm building the business, right? And a
Yes,
lot
yeah.
of like building the business is about like finding your positioning, and a lot of that is like based on you should be really leveraging like who you are as a person, and so on. And
Mm.
so I've been doing these kind of like reflective things about
Aha,
what has
right.
been my life story, what is the common thread in all of the different things that I've done. And I realized the common thread is that I'm always at the intersection of different domains and doing the translating between them.
Aha,
And so, in the early days, that was being at the intersection of theory and experiment. So with the
right.
theorists, I always like took on the experimentalist mindset. With the experimentalists, I took on the theorist mindset.
Mm.
Or, um, quantum information and quantum biology, or like spectroscopy and quantum optics, like
Right.
classical, or like, when I went to IBM, it was like research and software,
Mm.
um, and or like academia industry, always like at the intersection. And what it means is that I'm wherever I am, I'm always the outsider, which is kind of like not great. But I'm
It's good.
always,
Yeah.
yeah, always playing this like devil's advocate role as well. Like in the like tech circles that I hang out in now, where everyone's always talking about trying to get AI to do everything. I'm
Mm.
like the Luddite. I'm the one that's always like, no,
Yeah.
I don't want AI to do this. I want to do it myself. But then in the academic circles I hang
Yeah.
out
You're
in,
playing the
I'm
other
always
role
like
here.
the AI person that's like trying to get AI to do everything. And yeah, so it's funny. So I guess, yeah, coming back to what you were saying, yeah, all the theorists think I'm an experimentalist, which I'm not.
I know you're not. Yeah. But I mean, just want to make clear, I think the role of the interface is the most important part of interdisciplinary research at all, right? If you have domain experts, the communication barrier between two domain experts in different domains is insane. It's so immense that often conversations just can't start, let alone
Yeah, I know.
continue. And without the interface, without the person who's kind of good at both, it's dead. There's no such thing as interdisciplinary research. It's the most crucial role of all.
Well, it's not the most crucial, but it's
It,
it's an important component. Uh,
yeah, I think it's
yeah.
I think it's yeah.
Well,
Otherwise,
but
you
if you
just
didn't have if you didn't have the domain experts, there'd be nothing to communicate. So
you can
yeah,
always
they're
find
both.
another domain expert. They're a
Yeah,
dime a dozen.
yeah,
They're easy to
yeah.
find. Um, so the other thing that blew my mind was how about these guys. I don't want to say this because I did an exercise today, and I'm very interested in this all of a sudden. So Steve Yegi wrote a game. He wrote a game 20 years ago or something like this, and it's a semi-popular game, and it's become immensely difficult to support. Right, the number of tickets and things he has to do to keep it going, to fix all the bugs. He said he worked it out. It would take 100 years of 100-person years to get through all of these tickets. And he officially gave up programming as a consequence of this. It's just like realizing that there's not enough. Even if you just programmed until the end of your life, you actually wouldn't get through the to-do list of everything that you need to do. And it talked about other programmers just giving up programming because of this phenomenon that they can't get through their to-do list, and that everything's changing so fast that it just costs so much energy to retrain. And then with this agentic thing, all of a sudden he's reduced many of these tasks to things that can be automated, and all of a sudden 100-year to-do list has become a 1-year to-do list, right? Because he's accelerated and automated things by 100, a factor of 100. Like a factor of 100 is a powerful thing, right? So I did this experiment today. It was like there's all these research projects that I started and never quite finished, right? Everyone has this. Everyone. Like there's nothing special about this.
The back
It's
burner folder.
the back burner folder, right? And for me, they're littered over like 10 different storage mediums and notebooks and electronically and different things and so on. And it's this depressing thing, the back burner list. But it's also useful, like when a student comes to you and they have an idea, you say, maybe you work on this, and I thought, well, maybe if I could accelerate research by a factor of say 10, even a factor of 10, then maybe the back burner list could be worked through, right? And so how many things do I have on the back burner list? I went through, I have 37 things, 37 ideas that are kind of probably going to lead to something. And the time scale of one of these projects is about 6 months in the old time, right? You have to explain it to your collaborators or students. You have to work on it. You have to make a lot of mistakes. You have to do some numerics maybe, and then you have to like write it up. And writing up takes forever. And so 6 months to a year for each of these projects. So let's be pessimistic. Let's say 1 year for each project. I think that's actually realistic. So 37 times 1, that's 37 years, right? And so I'm reaching the point where I won't be alive to finish 37 projects. And so, is it time for me to hang up my hat and stop doing physics? Well, maybe not, right? Because a factor of 10 turns 37 into 3.7. So
yeah. So okay. Again, lots of follow-up questions. One.
Yeah.
Should all those projects be done?
I think so. I think they were all viable and interesting. And they're still viable and interesting. I went through the list. I immediately tossed out anything that was obviously garbage. I had plenty more.
Okay, good. 2, there's kind of 2 ways you could automate this. One could be better for the world, and one could be worse for the world.
Okay, let's see both. Yes.
Get all that. Well, I mean, there could be flow-on effects that are good for this, but one is to automate it so that the agents do it and like produce all of this stuff.
Yeah.
The other way is, there's a lot of students out there, around the world who really want to get into research, but don't have mentors, don't have anyone to give them an interesting first project to work on, and get them to the stage where they can start like doing research themselves. And so it would be so cool if you could somehow get these projects into a state that then some aspiring researcher could, who isn't necessarily your student that you're supervising, but someone could take this project and then work on them and maybe be guided with these like LLM or with these agents or something to help them train to become a researcher in the future and then be able to contribute to science legitimately. Like that seems kind of cool.
That seems like an awesome future. Yeah. So I like much more the latter thing that you said. Like, by the way, about the first thing, you get the agents to do everything. It's not that these guys talking about agentic coding are saying that that's what happens. On the contrary, they have 40 models or whatever, and they produce a whole ton of slop, and they have to comb through it to find the good stuff. So it's very human. There's a human role in what they're talking about. So
is that something like a more junior person could do, or do you still need the expertise to comb through the research?
See, that's the thing, right? Imagine if all the grinding derivations were automatable. I don't know, but actually the more joyful one is the latter way of moving forward. It's like bringing the project to a point where you could outsource the communication cost or something of allowing someone else to work on it.
Yeah.
Because 37, the year is also including the time it takes to talk with the people, right? You want to talk with your collaborators to teach them what it is, the tools they need to even understand the problem, and then they need to know the working methodology that might lead them to an answer which is good versus bad, and so on and so forth. It just takes so much talking.
It'd be great if it could just come up with a learning path to get you like to what you
Exactly that.
need to be able to
Yeah,
work on this research project.
that would be super, right? I mean, I know everyone would want to be mentored, and sadly, I don't scale by 37. That's
No,
the
no,
yeah,
no.
yeah,
Yeah, but that yeah, just I think the scaling problem is a problem. But that doesn't mean that the world should have fewer researchers and
right,
like
yeah.
people should be denied like the joy of becoming a researcher if they could, like then contribute. But then my next question is, say you do all of this research and
Hmm.
write papers and publish those papers, who's going to review those papers?
I know, what a disaster. Yeah, there's no more. Yeah, it's got to the point I just so overloaded. Like reviewing is impossible now.
Mm-hmm.
Now, yeah, I have no idea. But there again, I see the role of automated checking as a very powerful way to lighten the load of the referee, because the referee is often given the job of determining correctness and novelty.
Mm-hmm.
And correctness is such a grind. It's such a drudge work to go through and see other equations, like did they derive equations? Could there be mistakes in there? And if you really do it properly, it's going to take you years, right,
Mm-hmm.
to check every derivation. Oh my gosh, no.
I'm
And
going to be a cynic though and say that most people are not doing that.
I
So
don't believe they're
so
doing that. Yeah,
so
I can't believe
then
they're doing
that's
that.
not
But
really
they're relying
having
on
a
their gut feeling, right? So
yeah,
they'll look at
right.
the derivations and they'll say, "Oh, this is an absurd consequence."
Yeah.
I think there might be something fishy.
But I guess my point is that getting LLMs to do that won't save that much since people aren't doing it anyway. It'll just make it more rigorous, which is
Oh,
good,
okay,
but it won't
yeah.
save the time.
Oh, yeah. But the reason I thought this was interesting is because, in terms of creating papers, like if you had to get a certificate that the paper derivations were correct,
Oh, yeah.
imagine that
Wow.
it's passed the lean theorem
It's like,
prover
yeah,
test.
like when
Yeah,
it passes all the tests, like in a
exactly
software
that. Yeah,
program. Yeah,
yeah.
yeah.
You get this.
So,
You have
so
a
rather than it
certificate.
being like a PDF, there's
Yep.
like kind of another platform interface for papers where it's like past all the like
Exactly
correctness
that.
tests.
Yeah.
That's amazing. Oh yeah, I would love that.
Yeah, right. Imagine that, right? And so then, as a referee, you can pick up the ones that passed all the grinding derivation tests, and then
Mm.
you think about novelty.
This is great. And there could be like a new research area also to like developing new tests. Like, and you can have like
Yes.
test driven research, whatever the heck that
Wouldn't
is.
that be an amazing thing, right? I mean, it's not. I didn't come up with this idea, by the way. I mean, Terence Tao, I think, is going for this, and Peter
Okay.
Scholze in maths, right?
Yeah.
They're using this automated theory platform called
Mhm.
Lean to have a go at automating derivation checking in research grade problems, right? And they're heavy. It's heavy stuff, right? They're doing proper
Mhm.
analysis and things like that with these things. So that the fact that they're even thinking that that's a realistic thing to try at all
Yeah.
gives me hope, right? That it could extend to physics where we just do linear algebra anyway, right? So,
Yeah. So yeah,
but
not
t-
all physics, but yeah.
yeah, it's a horrible
Yeah.
lot of physics is linear algebra. Yeah.
Yeah, cool. And then bring the experiments into it as well.
Yeah, that is mind blowing.
Because you can also imagine in other fields, like more statistics based, kind of like life sciences, where
Hmm.
you wanted to also like check your data and say that, yeah, this is not fudge data, this is like legit data and everything. You
Yes.
can have all sorts of, yeah, automated checking. But yeah, then you really need to change the, like, you got to stop creating PDFs with
Yeah.
like text on. What the hell is that? That is just like such an archaic way to share information. Like presenting research, I think needs to. Okay, and here's okay. The problem with like the whole PDFs, like papers, is that each paper is kind of like its own little story, and that made
Yes.
sense when papers were making somewhat like big chunks of contributions. But now, if a lot of research is incremental, which doesn't mean that's not important. Incremental is important because you need
Yeah,
to
I'd say
like
so.
make progress. But if a
Indeed.
lot of research is incremental, it doesn't necessarily need that entire storyline around it. All of this is the background, this is the motivation, this is how
Yeah,
it fits. Like
exactly that.
this
Yeah.
is, I mean, it's good writing talking about, how it all fits into the greater scheme of things. But if you had a different way of presenting results where maybe there was a repository that was just like for all of the results related to some topic area, which
Hmm.
itself had the motivation, had the context and everything, and then you have a result and just like stick it in to like
Yes.
where it fits into this like schema, and then that gets automatically checked and stuff. Then you don't need to go through the whole like process, and you get your tick, you get your certificate on your like
Hmm.
on your CV. You can say you made this contribution. Like a paper, a new result can be like a pull request to some larger
Yep.
like
Yeah.
existing like thing, you know whatever thing of thinking. I don't have the right words right now. And then you get credit for it in the right ways. But like I feel like we're just repeating a lot of work that maybe isn't necessary in the context that we're in right now, that
Yeah.
made
Yeah.
sense
Yeah.
100 years ago but doesn't make sense now.
I mean, okay, the narrative aspect of the paper was important, and it for certain areas it's still, well, vitally important, because you're trying to get mind share, right? You're trying to convince people. The narrative is the part is the marketing, right?
Mhm.
It's the marketing around the project so that people will take notice. And if you write a very
Sure,
convincing introduction, then
sure.
maybe people who would have just dropped the paper because it seems super boring might get fired up by a good introduction. Maybe. Um, but
Yeah,
yeah,
I think for certain contributions to research that still makes sense.
yeah.
um, but for contributions where like it's clear that there's this body of work, there's a hole that needs to be fixed, uh, if you can just plug that hole without
Mhm.
like having to get all of the buy-in because it's just clear that it solves that problem, then maybe you don't need like the
It'll
whole
save you so
narrative
much
around it.
time. It will save
Yeah.
you so much time. I hate writing papers. Like, um, I don't even think I'm very good at it, and it's the roadblock for me. It's the critical path is writing
Mm.
papers. I just can't. I don't know. I can't even get motivated to write them anymore.
Mm.
Because of this, exactly what you're saying. Every project has to be have this wrapper around it, and I have such high standards as well, which is a bit stupid, but whatever. Um, and so I don't start anything, but maybe things are going to change there. But I do agree, and I wish we could value these incremental contributions more. Now, everyone has to. It's like LinkedIn. It's literally, research has become like the cringe thought leader nightmare of LinkedIn as well, in terms because everyone's incremental result now has to be phrased as a
Hmm.
uh, as a seminal result that opens a new field.
Yeah,
Otherwise, it
yeah.
doesn't get published, right? And but that's sort of it's completely ridiculous. If every result opens a new field, everyone knows that that's nonsense.
Yeah, yeah, yeah.
Then there's going to be infinite new fields. It would be so much better if we could value incremental research and give it the value that it actually has, as creating the
Hmm.
infrastructure which we build things on. Wouldn't that be great too if we could
Hmm.
engineer that social change? And somehow in software engineering, I get the feeling, but maybe you can correct me, that has happened, right? The with big projects, there's a lot of grind, there's a lot of incremental stuff that needs to be done, and
Yeah, like
but you get appropriate credit for it.
you
Can
get
that be
credit
true?
for,
Yeah,
yeah, because nobody is going to just build an entire like software package on their own. So
yeah.
the way that people used to measure it was numbers of pull requests, and
Okay.
like different pull requests get like categorized in different ways, whether it's just a bug fix or whether it's like making a like big change. So they had like ways of ranking like the importance
Mm,
of the pull requests, and then also the amount of code, like the lines of code that you wrote. So all of these were like ways of quantifying your contributions to a project, and you would get credit for that. And
mm,
now that's of course changing. I can do like a million lines of code,
yep.
pull requests to whatever, because I just get like cursor to write that. Like,
Yeah.
so AI has kind of like changed I think they're going to have a problem now with quantifying what makes, a good,
Well,
what you should get credit for. But this could be used as an opportunity for science to try and adopt some of those things.
Totally. I mean, I think you guys are just you guys. I mean, and now put you in the
I'm
role
not a
of the
software
software
dog.
engineer. Yeah. That was a slip, wasn't it? Software engineers seem to be light years ahead of us uh, in terms of managing projects and valuing contributions
And collaborating.
and
Like I
collaborating.
think,
Right?
like I
Amazing. Like
love that someone can come in from like anywhere and just like contribute to a project.
mhm.
Like they the documentation in a project is set up in such a way that you can bring yourself up to speed, make a contribution, and then people know how to evaluate the contribution and like accept it. Like that to me is great. I've been wanting to do this with research for so long.
Yeah.
Like to try and come up with a way to like apply those ways of doing research, for like collaborative. I think I have some like repo somewhere. I was calling this drip. I don't remember what that stand for. um Doing research in public, right? That's what it
Oh,
was. It
doing
was a
research.
way of
Okay.
like, yeah, doing research in an open way
Hmm.
that wasn't just open in the sense of like I want to be open about what I'm doing, but that anybody could come in at any point in time and contribute to like the project
Hmm.
in a way that didn't like require too many like resources from the other collaborators. So I thought that was like a really cool thing
I mean,
to
I
be
guess
able to do.
modularity is a key point.
Right, modularity is
Yeah.
a key point. Yeah, and
Yeah.
test and ways of testing
Tests.
is the
Yeah.
key point.
It's been solved before, right? These are not new ideas
Yeah.
in software engineering.
Yeah, but researchers are just really like it's a cultural thing. Like
Yeah.
researchers, for some reason, uh, I feel like they have a kind of mysticism surrounding what it is that they actually do, and so
Yes.
it makes it they're like not interested in processes. They're not interested in figuring out like
Yes.
they're not interested in making their lives easier.
Hmm.
They relish in how difficult what they do is, and
Yes.
so anything that makes it easier is cheating
Yes.
because they're not driven by the goals. They're driven by the okay. So maybe they are driven by the process. So I was wrong that they don't focus by the. I don't
I
know.
think I knew what you
I don't
meant
know.
by
There's just
process back
something
then. Yeah.
weird that
Yeah.
makes them
It's
not
this spiritual
interested.
mystic kind of aspect to
Yeah.
doing research and the idea of the lone genius and
Yeah. 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 Yeah.
yeah, and we talked about this before. I think
Yeah.
like this is toxic part of the social structure of of researchers. And wouldn't it be great if we could do exactly what you're suggesting this drip? And I mean, by the way, I I don't mean to diminish the credit for your project, but wasn't Michael Nielsen also at some point
Oh
trying
yeah,
to
it
do
was
something like
very
this?
much inspired by Michael Nielsen. I remember at some stage though going and rereading his book to make sure that I haven't like uh, yeah, that I'm not just repeating it. And I would say it's a natural extension of
Okay,
like the
because
ideas in his book. Yeah, yeah, yeah,
it's
yeah.
been a long
But
time. I
absolutely
heard from this
inspired.
from
Like he was,
Michael first,
yeah, yeah,
yeah,
yeah, yeah,
and
yeah,
so I was a
yeah.
bit curious if you were
Yeah,
building on
I
that
think
or
I think that I would need to go back. I mean, definitely on my repo that describes this, I give a lot of credit to the ideas coming uh, from him there. But I think the direction and the problems that he was trying to solve was slightly different to the ones
okay,
that I was trying to solve. I think he was very much uh, focused on the open aspect of it, like
true, yeah, right. It
not
was
so much on the mechanism of getting people to collaborate.
mhm. Interesting, yeah,
Yeah.
because but by the way, if you could pull it off, then I think you really would have vibe physics. I think you would have agentic research being enabled by
Well,
this.
okay, so this is the
Testing and
interesting
modularity,
thing
right? You know? Yeah.
is that all of this, when I was thinking about this like 5 years ago or whenever it was, all of this was imagining. Okay, so what I wanted to solve, one of the problems I wanted to solve is this business of uh, scaling, training people to do research.
Hmm.
And that there's like a lot of young people out there that want to learn how to do research, but there's not enough mentorship. And so I was like, can we come up with like a framework that someone who maybe is smart, motivated, but doesn't have like the experience, can they plug in and
Yes.
contribute to a piece of research and then whatever. So you needed all of these systems and stuff and processes. But now it like completely changes it, because I mean, this would not solve the original problem, but you can replace those people with agents, and
Yeah.
so
Well,
it can serve
or
as a
both.
framework of
Yeah.
yeah.
I mean, I love the original mission of what you were trying to achieve, and I think if we push the analogy with software engineering hard enough, then the role of humans in mentorship isn't gone either. Like, it's just
Mm.
you by making things more modular and more test driven, and with proper documentation in a way which is readable without understanding the whole. That will enable, of course, agentic style approaches, but scaling mentorship is a kind of parallel problem,
Mm-hmm.
and presumably in software engineering they're the same thing, right? So they must have scaling mentorship in software engineering as a problem.
Yeah, I think so much of it is like good documentation, because yeah,
Interesting.
a lot of the stuff that you get from your supervised PhD advisor, like if it was, if they just had these learning paths that were like well documented, they wouldn't have to like come up with a custom learning path for each student. And so
Okay, now I see.
um,
Yeah, that's now I see something that's actionable for me, right? So uh, if I could create good documented learning paths that would make my life easier, right? That's because
oh
I
yeah,
wouldn't have
man,
to.
this is actually interesting. Yeah, if professors started off by just, yeah, learning how to structure their research programs,
Yes.
like good software not programs, but whatever software repositories or something, I don't know, like
Hmm.
whatever it is that they do, then yeah, oh yeah. And I mean, okay, all the stuff I'm saying about software documentation, like 90% of the people get it wrong, right? Like
Hmm.
they like are not doing it well. Like there's this idea that of what you want to achieve, but most people do documentation wrong. So I'm not saying they have it figured out, but there's a lot of interesting thought leadership about like how to do good documentation, and I
Hmm.
wonder if that could be like translated, how to do good documentation for
Do you have any
yeah, for a research group.
examples of projects which are considered to be super well documented and
I don't have examples of projects. I can send you a link to a framework that we were like when I was at IBM, we were applying it to our projects that we were doing. I don't. This was not a universally accepted thing within
Mhm.
IBM. We were just kind of trying to
Oh,
like
okay. Yeah.
push it. But it was it was a. I think it's got a weird name, Deaxis or something. But
Okay.
I'll put a link in the bottom of
In
the
the video
YouTube
description.
thing,
Yeah.
and then I will
Yeah.
also send it to you. But I think but also I mean there are groups that are thinking about this. When I was reading all those grants, it was interesting to me seeing some groups, some professors talk about like how they run their groups, and they have like the Slack channels, they have like proper, a wiki for the group and everything, like everything is like really well documented. So people are thinking about this,
Yeah.
but I don't
Certainly.
know if
Yeah.
there's
Yeah.
any like frameworks that
Mhm.
people publish and that you can like adapt. I don't know.
But the learning part. Yeah. There's a lot to. There's a lot of food for thought here. Because I'm wondering what to do next in life, right? Now that things have clearly changed, right? It's whether I like it or not, right? AI tools are now a thing, and life will change as a consequence. And how to use that in a way that's meaningful and helpful. Um, and you've given me lots and lots of food for thought here about what to think about. But the idea of good documentation looks like something that I could automate with AI tools.
Yeah,
Um, yeah. So
that
I
is
mean,
absolutely true. Absolutely true. Yeah.
but the words documentation gives me like I have a almost physical uh, response to the word documentation. Like, it sounds like drudge work. It sounds grind. It sounds horrible. Like, I don't want to do it.
But the AI can help with that
But the
now.
AI can help with that, right?
Like
And
AI now makes like a whole repo, like with
yeah,
everything and like
and then you
everything
don't.
that you
And the
need.
trick is
Yeah.
apparently you don't just use one agent, right? You use like 20,
Hmm.
and then you then cherry pick out the stuff that's good. Like, a lot of it is slop, but out of 20 options, Like they have this formula they talk about. You want to maximize the number of options and minimize test time.
So you're talking about these agents working in parallel, but from what I've seen is like people create these like very big like loops with, this agent goes and does that, this is the research agent, it comes in, this is the like,
I think that's a mistake.
adversarial agent. Like you can build these like big
you can do
interactions.
that, but it's like there's a very simple formula, right? What you want to do is maximize the number of possibilities or options to choose from. That creates an innovation landscape of ideas, right? And then you want to minimize the time to test for goodness. So if you maximize ideas, minimize testing time, then you'll be able to explore the space of possibilities far quicker than if you
this is interesting. This is definitely not a framework I've come across. Like I see the agent stuff come up a lot, but I've not come across it this way, the way that you're suggesting to. Well, that Steve Aggie and his
I mean, I don't know if they invented it. They credit other people for these ideas. It's part of this mind blown experience that I've had. It's just like it's like, of course, right? You want to have. I remember Michael Nielsen saying this to me. Like Murray Gell-Mann had this quote: the way to do good research is to have a lot of ideas, a lot of bad ideas quickly." And what does that say? That actually, if you unpack that statement, it's what I just said, but in different words. It's right. You want to explore all the ideas and quickly test for badness. And if you minimize the testing time and you maximize the ideation or exploration of paths, that's good research.
Yeah. Because some people want to minimize their failure, but what they should be doing is maximizing their success.
I think they should be maximizing the space of things they try, accepting that failure happens.
But then that ultimately maximizes the number of things they succeed in.
Exactly. But I mean, there's this natural aversion that these physicists or mathematicians have. You don't want to try something wrong. Oh my gosh, right? The opportunity cost of a wrong idea is a lot, right? You spend a couple of hours following up this really wrong idea. Oh my gosh, what a disaster, right? But what you should be thinking is like, I want to be able to test for wrongness as quick as possible.
Right.
And then try out lots of things. Or make decisions quickly. And it's a completely different way of thinking. And I'm sure this is transferable. I mean, I only use maths and physics because that's what I know. But I'm sure this is transferable to many other disciplines. Engineering, at least.
Okay, so like I know a lot of people are hesitant about being wrong.
Yes.
And my guess is that it's because the environment that they've been in has been one where people make them feel bad for being wrong.
I think that's certainly a thing, yeah.
And so, I'm like middle-aged now, right? And I'm pretty sure I cannot think of like a single time in my life where anyone has chastised me for being wrong. And so I don't know if I just am so oblivious that I missed because I'm wrong all the time and I'm pretty open about it and I've never been made to feel bad about that. And so I don't know, have I been lucky? Am I oblivious?
Well, I hope that you've been lucky. Oblivious is maybe no. I don't think you've been oblivious, but maybe you've chosen the people in your social groups well. But I can certainly I can think of multiple incidents, particularly in my earlier career, multiple incidents where people would shame you for being wrong. Right? It was a classic way to shame your competitors is to find mistakes in what they were doing. You thought that A equals B, and I've experienced that multiple times. It's all about resources again. Like people want to gatekeep it, but
okay, but I've had people point out my mistakes all the time. Especially, and this is not a typical trait of a physicist, but I don't have very good attention to detail. So I had typos in my papers all the time. People even now people email me and they're like, "Oh, I was just checking this thing. Should there be a minus sign there?" You're probably right. And it never
test failed.
Yeah, so it's not that no one has ever pointed out that I'm being wrong because I'm wrong all the time, but I feel like it was never done in a way that made me feel ashamed.
I think you're lucky, to be honest. I don't think that's the experience of many people, at least I'm hearing from the people I mentor and people I don't, and that they experience a lot of difficulties interacting with the community, and one of the aspects would be saying something wrong, especially in a talk, the setting of a talk, or asking questions in a talk. People very, very shy about this because they don't want to be wrong and exposed for being wrong. And I'm glad that you don't experience or have not experienced that. That's great.
I wonder though if I have, and I just didn't realize. Like I just.
Well, which is then you're kind of bulletproof then, right? You got
No, I don't
steel
know.
armor.
I don't know. No, I almost feel like I. I mean, it's nice that you're framing it in a positive way, but now I'm getting like insecure and thinking like, oh my god, what if people have been saying all this stuff, and I'm like, yeah, I'm wrong.
But that's the best thing though, to accept being wrong, and to be proud of it, not in the sense like you're a contrarian, but like, yeah, I can be wrong, and I can admitting you're wrong as quick as possible is also useful, right? Because if you stick to a wrong idea too long, oh my gosh, does that cost you? That costs you so much, right? To keep supporting a stupid statement when it's clear it's stupid, and you come up with ever more ridiculous ways to support your stupid position. Very expensive.
I feel like I almost suffer in the opposite directions. Like there are some times that haunt me, like conversations that I had, like 20, 30 years ago, something, maybe not 30, 20 years ago, where I like look back on the conversation and like I now see that I was wrong, but I have no opportunity to
Oh yeah, yeah.
like talk to that person, and it would be super weird if I like how do
20
I
years
word
later,
tell them
you
like,
drop a line.
right, like I just want to say I was wrong. Like I almost
Yeah,
like hate not admitting that I'm wrong.
yeah,
To a fault.
it's like the 10 steps, right? 12 steps. It's
Yeah.
going back and admitting you're wrong to everyone. I mean, like I've screwed up a lot of lives. I worried about that, about saying wrong things to people in the past, and it's too late, right? They made decisions based on something I said. I don't know if I'll ever come to terms with that, but uh, you can always the best day to have done this is many years ago. The second best day is today, right? As long as you start admitting you're wrong quicker. This is not directed at you, I guess, so much as other people here. That's the faster you will become. Like agility comes from admitting you're wrong. It doesn't come from having the right answer first up. Although seeming like a mystic genius does, right? If you want to be a Feynman bro who impresses everyone with your mental acuity, then by saying deep things that are correct all the time, that's a good way to do it. But
Do you think Feynman said a lot of like bad, like lame stuff that just didn't make it into his publicity?
there's a whole Angela Collier video about Feynman. It's 2.5 hours
Okay.
long.
Okay. Wow.
It's really fascinating actually. Like there's many layers to the Feynman mystique, Feynman story, and as you dig deeper in the layers, like there's some authentic aspects to Feynman. There's a lot of created mystique around his
Yeah.
personality that's not real, is created by other people, not by himself. In and he promoted this as well. Like he enjoyed that people created this mystical kind of proto version of himself, and so. But there's a lot of toxic crap as well. I mean, oh my gosh.
It's kind of funny how like physicists seem to be so like anti-marketing,
Yeah,
anti-self-promotion.
exactly. Isn't it funny, right?
But then
But then
they're
they
so
do this, yeah.
susceptible. But they're not even do this, but then they're susceptible. Like they
Yeah.
idolize people
Yes,
that
yes, yes.
are good at marketing and promotion. They just don't see like those people are so good at that they don't see that it was marketing and promotion. Like
Yeah,
even a
yeah,
lot of like the gods of physics right now that everybody like aspires to. The reason they
yeah.
do that is because they were pretty good at like promoting
They're
themselves
pretty
and
good at marketing,
marketing.
yeah.
Yeah,
And I point this out to people continuously over the years, and they're like, "No, no, no, you're wrong." And I'm
yeah.
like, "I think I'm right."
You
I
wouldn't
think,
know about this person if it wasn't for that. Yeah.
yeah, you're not going to be recognized as a genius if you write these amazing papers, but they're difficult to read, and you're a
Mhm.
difficult person, and you piss people off.
Yeah.
It's probably not going to be recognized. Whereas if you really, oh man, I've
Although
got
there is a
three.
threshold above which, when you're already recognized, then you can
Yes,
get
true.
away with
That's true.
putting
You
people
can get
off
away with
and being
anything then,
difficult.
yeah.
But there's like you have to do one before you do the other.
I think it's like A then
Yeah.
B. And I just have so many images of people in my head right now who have just mastered this marketing to physicist game.
Yeah. Yeah.
There's some real masters of that. Real masters.
I have those images in my head too.
You probably
I
we're
don't
probably
think this
thinking
is
the
a
same
podcast
people.
where we shame people. So
No.
yeah,
No. It's a positive space where it's a welcoming space here. There's no judgment
yeah,
here. But no,
yeah. And
but there is something take home that's positive here.
okay,
There's an actionable
sure.
thing, which is admit to yourself that marketing is important, even in science. Like just admit it, or at least acknowledge that this could be true. Because once you start that path, then you'll understand that marketing is about communication and it's about allocating resources. Again, the allocation of resource here is time or
Mm-hmm.
or headspace or whatever. Like, why should someone invest their time in you?
Mm-hmm.
You convince them, right? You have to be convinced. I'm not going to invest my time in anyone until I'm convinced. That's a precious resource, time. And
Yep.
marketing is the tool where we convince people to allocate a resource to something.
Yeah. Spot
It's not
on.
a dirty thing. It's not an unethical thing. It's just the way in which we convince humans to do things. There's other ways to do it, by the way. If you're a billionaire, you can pay people to do it, so they don't have to be convinced. You can just pay people to allocate their resources to you. And if you're a dictator, you can do it as well, right? You just hold a gun to
Mm-hmm.
their head. So
Mm-hmm.
there are other ways to do it, but the nicest, most humane way to convince people to do things is marketing.
Yeah. Given that that's the business that I'm in now, I
Yes.
agree with you.
Yeah. And indeed,
Yeah.
it's also the business I'm in, peripherally.
Cool. It seems like we're at time. So
I
do
think
you
we've reached
wanna?
the point where this
Yeah.
meeting is officially over. Yeah.